So let's get started on the last lesson for this unit. Today's notes we will be starting in your video and we will actually be finishing in class. Part of what we are going to be doing requires the graphing calculator, and that's the part that we are going to be finishing together when you return to class. So today's main topic is what's called a line of best fit. So let's take a look at what that definition means. A line of best fit is a straight line through the middle of the data. That line can go through one of your data points, many of your data points, or no points at all. It's not required to touch any of them. And the third piece of it is, when you're drawing this line, we are looking for the line to have a balanced amount of points on each side of it. In other words, if you have 8 points, we'd like to see 4 and 4, or 5 and 3. We don't want to see 8 and 1. We want to see it nice and balanced. So let's take a look at some instructions and talk about what you are going to be doing today on your own. When you are making a line of best fit, you are going to do all parts of step 1 together. So what you're going to be working on is creating a scatter plot. When you are making your scatter plot, be sure that you use a constant scale along the X and Y axis. What that means is, when you're putting your numbers on your axes, count by a constant amount. In other words, count by 2s, or by 3s, or 5s, or 10s, or even 1s. Okay? And then secondly, label your X and Y axis with what the numbers actually represent. Okay? In other words, just give it a label. And C, finally, make sure that you title your graph. Step 1, all 3 of those parts are what you are going to be learning about in the video and doing in your notes. Step 2 requires us to use the graphing calculator. That's where we will come together as a group next class, and we'll talk about step 2 together. So that being said, let's take a look at our first example. You have data here that shows the height of each student and the length of their forearm. So the first part of it, we're going to make a scatter plot. I've provided you with a graph. What you can always make the assumption is the top row of your data is always your X values, and your bottom row is always your Y values. Now, when you're trying to decide upon a scale, the first thing I always suggest is look for your very highest and your very lowest values. So for your X's, if you look through this list of numbers, we have, it looks like 155 is your lowest, and it looks like 191.5 is your highest. And once you know your lowest and your highest, I always suggest subtracting them. So you would pick up your calculator and you would type in your calculator 191 minus 150, 191.5 minus 155, and you get a difference of 6.5. Sorry, I typed that in the calculator wrong. Sorry, you get a difference of 36.5. So 36.5 is what we need to cover span-wise. Then I count how many boxes I have. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes. If I divide that by 10, I get 3.65. That'll give you an idea as to what to count by. If we round that up to the nearest whole number, we get a 4. So I would say count by 4s or 5s. So I'm going to count by 5s. I'm going to start counting at 155. Now, the way we show that on the picture, because you can't just start wherever you want, it's called a break. Along the x-axis, draw a zigzag that shows the reader that you're not starting at 0. So I'm going to start at 155 and count by 5s. So then I have 160 and 165 and 170 and 175, 180, 185, 190, and 195. Notice I used most of my graph and managed to fit all the numbers in. Same thing for the y-axis. Let's look for the lowest and the highest. So it looks like if we look all the way through our data, I'm seeing 41 is the low and 50.5 is the high. So if we take 50.5 minus 41, we get 9.5. Well, again, we're going to count our boxes. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 10 boxes. Well, it would be perfect then to count by ones. So I want to start counting at 41. So I'm going to make my break again. 41, and just start counting by ones. All right, so now that we have all of our values written, now we have to do our labels. The x-axis, we just look back at the label on the table. It was height in centimeters. Our y-axis was forearm in centimeters. And now you just need to start plotting your data. So 185.9 is about right there. And we're going to go up to 48.5, which is right in the middle there. Then we go over to 172, which is about right here. And we're going to go up to 44.5. Then we're going to go to 155. And we're going to go to 41. Then we're going to go to 191.5, which is about right there. And we're going to go up to 50, and we need 0.5, so I'm just going to go a little bit above. Then we go to 162, which is about right there. And go up to 43. And then 164.3, which is really close to 165. And go up 42.5. 177.5 is right there in the middle. And go up to 47. 180 is right there. Go up to 48. And finally 179, which is really close to 180, and go up to 47.5. So there is your scatter plot. That's the part that you are doing on your own. The rest of it, okay, so we just completed A. In class, we're going to learn how to do B and C together. So that being said, we're going to move on to the next scatter plot. This data gives the number of U.S. births from 1990 to 1997. Now, there's something a little different here. It throws in where X is the number of years since 1990. And Y is in thousands of births. Okay. No. So Miss Simon has realized that my words, for example, too, do not match my data table. So we're going to ignore the words and we're going to use the data table. So our data table has hours without sleep. That is going to be your X's. And number of errors is going to be your Y's. So we're doing again part A only. Make a scatter plot of your data. So if we look at our X's, it looks like our lowest X is 8. And it looks like our highest X is 24. So we need to cover all the way along the bottom. Now we have a whole lot of boxes here. If you take 24 and you subtract 8, you only need 16 boxes. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We already have plenty. So we are just going to count by ones. So I'm going to put my break. and I'm going to put 8, and then 9, 10, 11, 12, all the way up to 24. Okay, so let's look at our y values and do the same thing. Number of errors. Looks like our lowest number is 6, and our highest is 16. Well, 16, take away 6, leaves us with 10. So let's take a look at how many boxes we have. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have perfectly 10. So we can go ahead and start with 6. I need to make a little break. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, apparently we don't. So we're just going to go up one more box and make a 16. Now we need our labels. The bottom was hours without sleep. And the side was number of errors. And now we're ready to start graphing our dots. 8 is right here, and go up to 8 right there. 8 again, but now we only go up to 6. 12, and we go up to 6. 12, and we go all the way up to 10. 16, and we go up to 8. 16 again, and we go all the way up here to 14. 20, and we go up to 14. And 20 again, but we stop at 12. 24, we go all the way up to 16, so that was that extra box up here. And 24, and we go to 12. And the one thing that we are missing is our title. So we could say, how sleep affects errors. So how sleep affects errors. And we are done with that one. So let's look at example 3 that has something a little bit different. The data table shows the concentration of carbon dioxide on top of a volcano since 1990. So we got our years and our CO2. We need to make a scatter plot of your data, but X is something different here. X represents the number of years since 1990. So we are not going to actually use the numbers 1990, 1992. We want to know how many years have passed since 1990. So our years go on the bottom, that's our X's. CO2 is our Y's. So our first year is 1990, and our last year is 2004. Now, here is a smart thing about this problem. If you look at the years, they all go up by 2's. If that's the case, then we're going to count by 2's. 1990 is 0 years from 1990. So 0 is my first number. 1992 is 2 years past 1990. 1994 is 4 years past. 1996 is 6 years. 1998 is 8 years. 2000 is 10 years. 2002 is 12. And 2004 is 14. And the y-axis, let's look for our lowest number. Seeing 354. And our highest is 377. Well, if we take 377 in your calculators and subtract 354, we get 23. Let's see how many boxes we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. We have 25. We have plenty of boxes. We can count by ones. Now here's what I would do though. I would count by ones, but I would skip a line. So I'm going to draw my break. I want to start at 354. I'm going to skip a line and label the next one 356. And then 358. It just makes it a little less squishy. And you can keep going. Whoops, that one did not skip a line. 362, 364. And where are we stopping? We need to stop at 378. Why did I write 670? That just makes it a little more spaced out so it's not nearly as squished together. So let's do our labels. I'm kind of out of room here. I am going to move that up and say my years are down here. And then my y-axis is, it looks like CO2. And the units are ppm. So 1990, we need to go to 354. That's this very first spot. 1992, we need to go up to 356. 1994, 359. 1996, 363. 1998 is 367. 2000 is 370. 2002 is 373. And finally 2004 is 377. Okay, so that is that scatter plot done as well. And again, we'll do parts B and C together. This last slide of directions, you don't need to worry about this. This is part of your notes, and this is the calculator instructions that we will be using next class. So this will help us find the equations, and then we'll finish talking about how to finish all of this. So if you would like to start on your homework, the part of the homework that you're able to do is you can make your 4 scatter plots. And then again, the rest of it we will finish in class. So see you next time.